So, problem number 1. How did I want you to set this up? What did we do? Do I move the 10 over and go and factor it, or do I do something else? Yeah, to go y equals on both. So I'm going to go y equals x squared minus 3x, right? That's the first one. Oh, let's make this a fatter thing. That'll work. And then I go y equals 10 the other side. So that's just a horizontal line, right? Equals 10. And then I have to kind of scroll and find it. All right. So my answers are, I'm only worried about the x answer. So I get an answer, hello.
Sorry.
You're perfect. Good seeing you. Oh, boom. Got it. So the x answer is the only thing we're worried about. So we had an answer of -2 and +5. Okay? We don't have to go any further than that. We don't worry about the y component. Okay? Does that make sense? And then we get to number 3. Now number 3 gets a little goofier. The reason that 3 is going to get goofier is we're going to have a horizontal line at 275. Right? All right, so the left side is y equals, let's see, 10x, and then plus 25 parentheses, x minus 3. So that's that green line. Agree? And then the second one I'm going to go just y equals 275. And again, the nice thing with Desmos is we can just finger drag, or you can hit the minus sign until you find where the two intersect. So where the two intersect is at, I'm going to zoom back in to make sure I have the right one. So my answer is just 10. I don't worry about the 275, the y component, because I'm only solving x. Is this helping you out a little bit? Okay. And I said to skip number 5. Is that correct?
Yes.
Okay, cool. And then we get to number 7. Number 7, we have y equals, we have x and then parentheses, and then 5x minus 2, parentheses, open parentheses, x plus 7, close parentheses. So that looks kind of like that. And then what I want is also I want y equals 0, which is the x-axis, right? So if you hit your home button, again, I'm only worried about the x values. So my answers are -7, 0, and 0.4. Feel comfortable so far? Number 9 is done the exact same way, right? So I'm just going to get rid of this one, keep that one, and go y equals x, parentheses, 3x plus 4, and x minus 5. And again, we're worried about these values. So only look at the x value of the point. So I get -1.3, I get 0, and I get 5. Good so far? All right. Any questions so far? What? Can't talk. Of what we've done. Seem okay? Is this answering your questions, or have I got to your question yet? Not calling you.
Wait, I was just confused. Do we just write it as x equals negative, or do we have to do...
Not factor in, just x.
Okay.
I mean, Desmos does the work for us.
Okay.
Which is beautiful, in my opinion. All right, then we get to number 11. We have 2 linear equations, it looks like. So I have y equals 26 minus 3x. And then we have y equals 4x minus 9. All right, so you need to just kind of scroll to it, and I'm looking for the intersection. So my answer to that is just 5. Or actually, we're going to use both answers. We're going to use the x and the y because we had x and y there. So that's going to give me 5, 11. That's the intersection of the two. Okay? And then we get to the intervals. Okay, the intervals for inequalities. Okay, can I move off this screen? You good? So, a few things that we have to recognize. Hello. Business Calc. Are you my newest?
I guess so.
Hey, this is going to be your chair here.
All right.
Even though there's some empty. We do this every day. That, snap.
All right.
Got it?
Good.
And you got that comfy chair. And you got this packet. So nice to see you. We're on the second page. Or I guess the third page if you count the back page as the second page. This is my biggest class. I think there's 32 in here. It's awesome. All right, I get to number 13, agree? So I have the quantity x minus 2, and then I have x plus 3. Oops. Go back, put it in a parenthesis, move forward, plus 3, close parentheses. And then the nice thing is, Desmos has the inequalities right here, so we can just type it directly in, and lo and behold, it does some neat stuff for us. So we talked about this yesterday. Why do we have a dotted line versus a solid line for my graph itself? What took place on that one? It's because the inequality sign doesn't have the equal, the little extra bar underneath. All right, so here, it's not going to really tell me. Here and here, those regions, actually if I come down here, this will probably help though. So right there, that, so negative 3 and positive 2, that's going to be where my answers are going to take place. Now, we want values that are greater than 0, so we have to use the shaded region will define what our answer will be. Meaning, so let me put this on back on this screen. So I have basically x equals 2 and I have x equals negative 3, where this is where it would cross the x-axis. So 1, 2 we have basically here, and then we have 1, 2, 3 basically here, and then they shaded over here and shaded over here. I know my drawing isn't quite as nice and neat as Desmos, but I think we can go with it. So the shaded region is where we want to define our answer. So way over to the left is negative infinity, way over to the right is positive infinity. So our interval notation for this is going to be negative infinity to negative 3, and then it's going to be 2 to infinity. Now, you might have heard this term before. Those are parentheses, but sometimes we refer to them as soft brackets. Does that make sense? The reason the soft brackets take place is our original problem, which was this. This is instituting soft brackets. And then the infinities always have a parenthesis or a soft bracket. Okay, because we can't theoretically ever get to infinity. Okay? Does that problem make sense? Okay, so let's take a look at number 15. Can I move off this screen? All right, let's go back to Desmos, and let's go ahead and plot in what we can do. So I'm going to go 2x plus 1. And then I have x minus 5. And And then the inequality is this sign, has a little equal sign. So this can mean we're going to have a solid line in this case. Okay, so for this particular problem, if I look at each of those x component values, I have negative 0.5 and I have 5. If I plot any number into those x values between negative 0.5 and 5, this would mean this creates our positive region, meaning it would be above the x-axis for an answer. Okay, so if I plug anything in between those two in, so I'm going to go, I have negative 0.5, and I also have 5. Okay, these are going to be hard brackets. And the reason these are hard brackets is because I have this sign right here. Oh, actually I said it wrong because we have it. Did I plug it in right? It's less than, yeah. Okay, if I plug in anywhere between negative 0.5 and 5 in, my answer would come out to be a negative answer. I said it wrong originally. I apologize. Okay, the reason they're hard brackets, this little line inequality, that's going to give us hard brackets. But if one of our sides was going all the way to infinity, the infinity would always have a soft bracket or a parenthesis. Okay, friends, that's the front page. Is there any questions on that front page that I didn't help you out with? Okay. All right, we are on the back page. So number 17 is our first problem. So it says solve using logarithms, round all your answers to the nearest hundredth. Sure, I could go with logarithms if I wanted to, but let's face it, no one reads directions. We're going to go survival mode. Okay, so I'm going to graph the left side as y equals 9 raised to the 2x power. Okay, so that's what the first equation looks like. And then I'm going to do y equals 27, and that's going to be raised to I'm going to use the a to the b button, this button here, to the x plus 1. Oops. So notice what happened. It didn't allow me to keep it upstairs. So I want to keep it upstairs, so what do we have to do is this. I'm going to move back here. I'm going to put this in parentheses. The other one worked because it was being multiplied together. But if I want the x plus 1 to stay upstairs, we're going to get that. Okay? So now we have to kind of figure out where these two are going to cross each other. So I could come upstairs and we could go up here for a while. I mean, I'm getting to some pretty big numbers. And it doesn't quite appear that my two lines are going to come together. I mean, I'm in the hundreds now. Agree? And they're still parallel to each other. Okay? So that means that they're not going to cross there. So we're going to look somewhere down here. So I'm going to tap on the lines and see where I might get an intersection between the two. And I'm not seeing it right away. Okay, so now we have survival that we could try and also do, going, I'm not seeing where they're going to cross. So like I'm going to try and plot, but I don't know if I'm not getting an exact. Notice how if I push on it, it's showing up, but it's not there. So that either means way back here, there might be a dot someplace. Oh, is it here? No. So I'm not seeing a dot. Okay, So these are eventually crossing at some location. They're eventually crossing at some location. So does anyone have an idea of how we could use Desmos that would help us? Any thoughts? Well, I'm just going to plot the original problem in. So I'm trying to survive. Like Stirrup says this is going to work. I'm just going to plot it just exactly as it is as our problem. And this is going to give me x plus 1. Okay, so let me turn these two off. Now I need to search for it. I'm going to hit home first. Oh, okay. Right here, this x value here, where it's crossing this value right here, which I'm not seeing right away. So I'm also going to do this. I'm going to type in x equals 0, or excuse me, clear. I did the wrong letter. I meant y equals 0. Okay, what's taking place here? So my friends, I would say that my answer should be at 3. Exactly 3. Okay, so the answer should be 3. Okay, so again, I just plotted this. This gave me this weird straight line, which is just telling you where they're going to cross each other. I had to then cheat it a little bit and saying, hey, I want y equals 0 to also come up. So let's see if 3 works. I'm thinking that my answer should be x equals 3. And I'm like, well, how would I test that? Well, I'm going to plug it in here, and I'm going to plug it in here. I want to know if these are equal. They tell us they're equal to each other. Oops, hang on. I got to restart this. Sometimes this, when I'm recording at the same time, sometimes my smartboard goes goofy. So I have to restart it. It just makes a weird shaded line. Technology is great until it doesn't work, right? Okay, so we know that this is equal to this. So now, we found using Desmos that x equals 3. So if x equals 3, that means that 9 raised to the 2 times 3, or 9 to the 6th, is equal to 27 to the, so 3 plus 1, so 27 to the 4th power. So how can we, and I realize I'm trying to stay away from the logarithms. Logs work great, don't get me wrong. Logs are something that the community of math really should get away from, because logarithms were created to handle very large numbers when we didn't have technology. But now we have technology. So I want to know, is 9 to the 6th power, 9 raised to the 6th, which is 531,441, is that equal to 27 raised to the, what was my 27 raised to the what? 4th? Lo and behold, they are identical answers. Okay? So it's just a matter of, little struggles are totally fine. And then, yes, we could sit there and we could use logarithms, which would be calculus based, but I'm trying to teach you an alternative way of reaching it. Okay? So then we have 125 x minus 1 equals 25 raised to the 3x. Well, can I delete these? Please. Someone's going to say, wait. And you're like, uh-oh. So I saw my struggle on the last one, so I'm not even going to worry about trying to graph them. I'm just going to go 125 raised to the, and I have to put it in parentheses because it's x minus 1. And then corner over, and I'm going to say equals 25 raised to the 3x. I'm going to hit home, see if that takes us anywhere. Okay, cool. So right here, I would say that that's got to be 1. Or negative 1. Do you feel comfortable saying negative 1? So if that's negative 1, that means that 125 raised to the negative 1 minus 1 is negative 2, I believe. So it gives me that. And then 25 raised to the 3 times negative 1 is negative 3. Are they the same answer? Do you see how I got the answer of being 1? So my answer technically on that problem is x equals 1. Or x equals negative 1, excuse me. And then the last problem, because I don't have exponents on both sides, should work for us pretty nicely. All right, so I have y equals 3.6 raised to the 2x power. And the reason I'm graphing this one is 47.2. I can easily get that. Y equals 47.2. And now I have to find it. So I'm going to scroll up here. Let's see, whenever I get another line. Oh, here's my intersection. Cool. Okay, my y value, notice, is 47.2. That's what we want. So I'm solving for x, so my answer to this one is 1.505. That's all it is. Okay? All right. Can I wow your brains for a minute or 2 or 3? We're out here at 10:06. Okay. So let me ask you this, and I have a video that I'm going to show you that's going to go along with this. If I were to take every number what do you think all numbers would add up to? Like if you were to go on your calculator, go 0 plus 1 plus 2 plus 3 plus 4 plus 5. Is it going to equal infinity? What's it going to equal? Anyone know? So the summation, this means add up, of all numbers from 0 to infinity is going to give us negative 1/12. Okay? Come on, pencil. Stop working. That's supposed to be a 2 down here. So negative 1/12. Let's see why. Ready? We're going to go to a group called YouTube. I don't know if you've ever heard of this or not. Sum of all natural numbers. It's about an 8-minute long video.
For no reason at all, I asked Mint Mobile's legal team if big wireless companies are allowed to
skip. Pause. Now I have to go back here. Go here. Stop sharing. And go back to share. Continue. I'm going to do this. Turn my audio on. And I'm going to share. There it goes. All right, this is going to boggle your minds. It's not the hardest thing to learn about. These guys are a couple of crazy physicists. They got PhDs and probably more things than I need to know about.
1 plus 2 plus 3 plus 4 plus 5, and that's set here into.
Let's go back to the beginning.
I'm going to give you an astounding result.
Astounding.
Astounding
So I'm
result.
just going to write down a little sum. I'm just going to see what answer it gives.
1 plus 2 plus 3 plus 4 plus and I include all the natural numbers, all the way up to infinity.
So what do
you reckon the answer to this is, Brady?
Well, I would say it would tend towards infinity.
Yeah, that makes sense, doesn't it? The answer to this sum is remarkably minus 12.
It's amazing.
It's amazing. I mean, I first saw this result when I started learning a bit of string theory, and what's even more bizarre is that this result is used in many areas of physics. This is a very well known string theory textbook by Joe Polchinski. As you can see, sort of quite early on, page 22, we have this statement here, which is that the sum of all, this is basically saying the sum of all the integers, or the natural numbers, all the way up to infinity, is 12. Alright, so we're going to prove now, without getting our knickers in a twist with Riemann zeta functions, we're going to prove quite a simple way why the sum of all the natural numbers is indeed minus 12. So to do that, we're going to have to do this in a number of steps. We're going to look at a few different sums. The first sum that I want to look at, I'm going to call it S1. And it's 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. That's the first sum I'm going to look at in principle. The second sum I'm going to look at is 1 minus 2 plus 3 minus 4 and so on. Carry on in that process all the way up. And the third one is of course going to be our one that we're really interested in, which is 1 plus 2 plus 3 plus 4. So we're going to evaluate all these three different sums. Now the first one is really easy to evaluate. We need to attach a number. Now clearly, what is the answer to this? Now you stop this at any point. Okay. If you stop it at an odd point, you're going to get the answer 1. If you stop it at an even point, you'll get the answer 0. Clearly, that's obvious, right? So what number are we going to attach to this infinite sum? Do we stop at an odd or an even point? We don't know. So we take the average of the two. So the answer's a half. There are other ways to prove that this sum is a half, by the way, which we can do if you want.
No, there'll be a link. There'll be a link there because we've done it before.
Okay, good.
You'll see the link there.
Okay, so this is a half. But I think intuitively that's the easiest way to say it, that you either get 0 or 1 and therefore you just take the average. So this is the natural number to attach to this sum. But once we know this, we're laughing. Okay? Because from this we can achieve everything that we want to achieve. So the next step is to find this sum. So what I'm going to do is I'm going to take 2 copies of this S2. Okay? So I'm going to add it to itself. So 2 times S2 is equal to, let me just write it out. So I'm going to write it out twice. 1 minus 2 plus 3 minus 4, so on. And then I'm going to add to it itself, but I'm going to shift it along a little bit. So that's plus 1 minus 2 plus 3 minus 4 and so on. Okay, I've just taken 2 copies and added them together. But I've done it in a particularly nice way, and I just push this one along slightly on the bottom. So now you see what you get. You take this one and this and this, and I get 1. So 1 plus nothing is 1. Minus 2 plus 1 is minus 1. 3 minus 2 is 1. Minus 4 plus 3 is minus 1. And so on. And I'm going to keep getting this pattern. So hang on a minute, I've just got back to the sum that I started with. Which I know the answer to. So half. Okay. So therefore I know this sum now. So it's divide through by this 2 and I get a quarter. So now I know that this sum, the second sum, is somewhere the signs alternate.
So what he did there is he had 2 S2, 2 times S2. If I took S2 and I added it and I kind of off-shifted it, I'm going to get what S1 is 1 minus 1 plus 1 minus 1. And then what he did is he divided both sides by 2. So then you got S2 is equal to 1/2, or 2S2 is equal to 1/2. And then he divided both sides by 2, so you got 1/4. You following what he's doing? Like, wait a minute. And he's just adding and subtracting.
So this is my second remarkable result. Now I have everything I need to prove this crazy minus 12 thing, right? Okay, so let's do it. I'm going to take this one, and I'm going to subtract this one. Okay, so I'm going to subtract S2 from S. Let's write them out again. Okay, so I'm going to write out S first, which is 1 plus 2 plus 3 plus 4 plus 5 and so on. Okay, and I'm going to subtract S2. So that's minus. Okay, let me just put a bracket in now because I'm going to minus all of this. 1 minus 2 plus 3 minus 4 and so on. Okay. 1 minus 1. What's that? 0. Yeah, exactly. So I get nothing from that bit. 2 minus 2 is 4. Okay. 3 minus 3. 0. 4 minus 4 is 8. And so on. And the next one, I'm going to get from the 5s, I get nothing. From the 6s, I get 12, and so on. And it proceeds in that way. And now you can see we're almost there now, right? Because look what I've got here. I've got 4 plus 8 plus 12. If I take a factor of 4 out, it's 4 times 1 plus 2 plus 3. Okay. It's my son that I want. Now I've got a formula for my. So this is just 4 times S, which is my son. Now I just solve this equation, right? Because I know what S2 is. So I have now the expression that S minus, because I know what S2 is. S2 is a quarter. Is equal to 4S. Okay, I take S from either side, so I get minus a quarter is equal to 3S, which implies that S equals minus 12. Now do you believe me?
That's amazing.
I love it. It's amazing.
Tony, if I got a calculator out and wrote 1 plus 2 plus 3 plus 4 plus 5 and I sat here until the end of everything and then pressed equals, would I get minus again?
How do you mean the end of everything?
You can't do it to the
end of everything, can you?
So, see, the point is,
I know this looks like a bit of a mathematical hocus pocus sort of thing, but actually in truth it's not. And I'll tell you why we know it's not.
And I know
you think I got about physics too much, but we know it's not because of physics, because these kinds of sums appear in physics, and in physics we don't get infinite answers. It's amazing, and it's just, I was trying to come up with an intuitive reason for this. To be honest, you have to do the mathematical hocus pocus really to see it, and then you just have to believe that you're not measuring the physical infinities in nature, and then those two facts together, I think, give you confidence in this result. But it is clearly counterintuitive. It's counterintuitive because intuitively you just want to stop the sequence, and the minute you stop the sequence, then all of your intuitions for this result goes out the window.
So if I do 1 plus 2 plus 3 plus 4 plus 5 and I go back to a Google clicks,
you'll get a big number. Yeah, you won't
get anything like minus a 12.
You have to go to
infinity, Brady.
It's negative.
I've added all these positive numbers together up to infinity, and I've got minus a 12.
But it does play.
Anybody baffled by this whole thing? So it's just kind of a fun thing to think about. If you added up 1 plus 2 plus 3 plus 4 all the way to infinity, you get negative a 12. It's like, but how can you add negative numbers or have positive numbers together and wind up with a negative answer? It all deals with series, and when you start dealing with series of numbers, and we're not going to deal with series, I just wanted to kind of scramble your brains a little bit and have a little fun. Kind of cool. Has anyone ever seen that before? Okay, well, it's posted. It'll be posted on my video if you go home saying, Stirrup's crazy. He told us that all the numbers add up to this. Well, it's on my video, so you can play it to parents at home and have some fun with it. So what I want you to do for an assignment, we have about 6 minutes. What do we say? What do you say we do this? I don't know if my pen's going to work any longer because it's... All right, so I got to go to this. Page. We don't really have pages. Algebra review. Oh, If I could spell, I'd be much better. Let's see. I took some time, so I'm, what do we say we do? 16, 18, and 20. What's the comment? Not too bad, is it? 3 problems just on that backside of that page. Have some fun with it. And now you're sitting there still going to be figuring out why in the heck does this.